out. Okay, hello everyone. This is from 0 to 98. It's testing up your, speed up your testing of DaggerMock and Live Kaspresso. I'm DiPatri, and I'm from the Comcast Corporation up in Philadelphia. Oh, and by the way, Christian, see if you can mute everyone. And so this talk is actually a code lab that I wrote. It's available at this link. And you can just go to that. You can follow along, or you can wait until after the talk and you can go over anything that you missed. But the point here is that the prototype to production pipeline for mobile applications doesn't always have the luxury of test-driven development. As a result, some production code is very low unit test coverage. So today we're going to learn how to use Espresso in new ways to quickly stand up live end-to-end integration tests. So these tests give us confidence so that we can safely move ahead with feature changes, adding things to the app, while we slowly build up our unit test coverage from 0 to 98%. That's a process which can take weeks or even months. So I was trying to think if we could come up with an app. What's an app we could write together today that would help us demonstrate the concept of going from 0 to 98 as quickly as possible. So since this kind of sounds like speeding to me, I thought I'll make a siren. Can everybody see that okay? I can't see my screen. So Christian, can you see that?
Yes, you're looking
You're
at
muted. Okay, I'm sorry about that. Yeah, excellent. Okay, so this is my police siren that I made, and you can see it's got a microcontroller up here. It's got an antenna, Wi-Fi module. This microcontroller is made by a company called Particle. Okay, and so I'm going to remote control this police siren from the mobile app, as you can see here. Everybody can see my screen okay? So we're just going to go ahead and look at this, and we're going to launch this app. Now, again, this app, we built it in the code lab. Again, we're just going to use it to control the siren. So the siren's off. So we come over here and you can see it shows the current state of the siren. So I hit the button, turns the siren on. Here it queries the state of the siren. And now the toggle button now can let you turn the siren off. Okay, that's the app. And again, we're going from 0 to 98. So, okay, so let's assume, right, that this app is really complicated. Okay, we're doing a little role playing here. Let's assume this app is really complicated. It's thousands of lines of code. And let's say that I just joined the company, right? I was hired, maybe a contractor, to add some new feature to this product. But I'm really concerned because this app has no unit test coverage. Okay, that's concerning, right? Especially because I don't know if I'm going to break any existing functionality when I add my new feature. So we can protect our entire app with a live end-to-end Espresso test. Okay, so I call this live because we're going to use a real external hardware, right? We're going to use a real endpoint. We're using both the real siren and the cloud component, which is how we talk to the siren, right? We're going to use all that in our test. That's why it's live. Okay, I call it an end-to-end test because I'm going to test the app in its entirety. I'm not going to, everything we run in the app is going to run in the tests. And the reason I make these choices primarily is because mocking anything out requires us to have a really good understanding of the app. And remember, I just showed up on the job, or I'm fairly new to the job, and it takes months to retrofit an app with proper unit testing. I don't know the app that well, so I really can't mock. It's kind of like, it goes without saying that to mock means to know, right? So we can't really do that. So we're going to use a live end-to-end test to start off here. Now, to do this, it's going to require some tricks. So we're going to learn about those tricks now, okay? What we're going to do is we're going to, well, let's first look at a very simple Espresso test that we'd write. So again, we're going to dive into the app here. Now, we're going to look at now this, again, this is from the code lab that I sent you a link. It's right here. And you can look at that. It's a very simple app, but the Espresso test hasn't been touched. This is like the basic Espresso test that you get out of the box. Okay, so we're going to delete this and we're going to write our own Espresso test very simply. And we're going to assert this screen, right? This is our existing functionality. We're going to assert this part where it says the red siren's off, okay? Now, to do this, now this is going to be a live coding exercise. I'm going to use live templates, which is a feature of Android Studio, which lets me do that. Boop, very quickly show you code, okay? So this, for those of you who aren't that familiar with Espresso, the way it works is first it compiles your app and it installs your app on a real device, okay? And then it launches your desired activity that you want to test. In this case, the main activity. It's the only thing I know about this app is that it has a main activity. So this launches the activity. So now let's go ahead and write a test to assert our screen. In fact, we're going to assert this screen right here, right? So let me do that. Oh, that was impressive. Okay, so there is my espresso test, nice and simple. Right, so we're asserting that when the red siren is off, the application looks like this. Okay, so the first thing we do is we launch the activity. And remember that installs the app and then it launches main activity. Now the sleep is here because if you remember, when I launched the app, it has to query the state of the siren. It has to make a network call to the Particle Cloud platform, right? To determine the state of the siren. And it puts that here. Now, the problem is if I didn't have this, please understand that Espresso is a multi-threaded test environment, right? You have the main thread of your app running here, and then you have a test thread, which is different. This is unlike the default behavior for RoboElectric. This is a different thread. So if I run this and immediately jump down to the test assertion, right, there's going to be a problem. Okay, there's a problem. Okay, right. So I messed up here. Let me fix this. The dreaded missing brace. Okay, so I need to sleep here to give the application time to make that network call. Okay, now, if I knew the application very well, if I was like an embedded developer and I'd been doing this thing from the beginning, we would use more sophisticated ways of synchronizing the test thread with the application thread. And one way to do that is idling resources in Espresso, right? And depending on if we're using coroutines or RxJava, we would do that different ways with idling resources. But again, just like the mocking argument, using idling resources requires a thorough understanding of the app. So we can't really use that. So the sleep is what we're going to have for now, okay? And then once we give the app long enough to query the state of the siren, we're going to go ahead and use Espresso's domain-specific language, DSL, to assert that red siren is off is displayed here. So let's go ahead and run this app. I'm sorry, run this test rather. Okay, we're going to right-click, run. So it's building, it's installing the app, right? Remember I said it installs the app, and then after it installs the app, it's going to run it. Now, we expect this to pass because the siren is off, right? The external system is in the correct state for our test, and the test is going to pass. Did you see it said standby, right? So we waited 5 seconds, and then now we're going to start. There you go, the test passed. Now that's great, right? So we're on the right track here, right? But the problem is we're using a live end-to-end test. So if anybody's done this before, the first challenge you encounter is it's a live system, right? This thing, right, can be on. It's a multi-tenant environment, right? Many people use this. Well, nobody uses this stupid thing, but this is a metaphor, by the way, for like a real world live system. This could be a database, it could be an account. In this case, it's a goofy red siren. The point is, it's on. So if we run our test again, one might expect it to fail. And one would be correct. It's going to fail because the red siren's on and the test fails. So how do we fix this problem? Well, remember, the whole reason we're doing this is we're trying to go from 0 to 98 very quickly. We're trying to get a live end-to-end test, which gives us an effective test coverage of 98%, right? But the problem is our live system is in an unknown state. We need to somehow get our live system in some kind of a state that's reliable. So this is kind of a flaky test at this point. How do we solve our problem? How do we fix this very quickly? Because we still don't have time to dive into the code. We want to be done with this, right? And be able to move on with our feature development. So what we're going to do is we're going to use a relatively new open source library called Kaspresso. So what Kaspresso does is it wraps our code, it wraps our test in some extra logic that helps us deal with flaky kind of external states that we're dealing with here, okay? So first thing we need to do in order to use Kaspresso is We need to embrace this notion Martin Fowler had once mentioned called page object. And the idea is that when you're doing testing, you want to abstract out, the real screens that you're working on into what you want to test. So in this case, we're testing the text field and the button. So we have to make this thing called a screen object in order to use Kaspresso. This is kind of like something you have to do. So you just got to do it. So, so we're going to go in here, and this thing is called, we're going to call it main screen. And this is a top level object. And it's going to extend a K screen. So you have to use this in order to use Kaspresso. Okay. And it's a main object. And then we're going to do more live template magic. Whoop. Now, what we have here, this is the real implementation, right? It's the layout file, the main activity. What we have here is the abstraction. These are the two things that we can assert when we're looking at the screen and we're doing testing. So it gets rid of all this stuff from having to go in your tests. It just makes the test easier to write. That's the first step for using Kaspresso. So now let's see how we're going to use this abstraction in our test to make our test more reliable. Remember, the whole problem here is this is unreliable because it's a live end-to-end test. Live systems are unreliable, unpredictable. We're going to try to fix that. So the way we're going to fix it is we're going to, well, first we have to, our test has to extend this new thing called test case, okay? And then we're going to get rid of this stuff. And now we're going to inject our Kaspresso code with some more live template magic. Okay, so this is our original Espresso test down here. Here we are, this is our main screen abstraction, right? And so the two things that we can talk to are the text view and the button, right? Those are our UI abstractions. But what I want you to see here is that we've taken our original Espresso test, and we've wrapped it in this code block called Flaky Safety, right? Whatever, Flaky Safely. I have a hard time saying that. Flaky Safely. What it does is something interesting. But first, I want to point this out, button click. So what this does is if the siren is on, let's say you start the test and the siren's on, this button is going to turn the siren off and the test is going to pass. Yay. But what if the siren is off when you start the test? This button click is going to turn it on, right? So you don't know the current state of the siren. Your test doesn't know the current state of the siren. So it just has to kind of try both. And if one fails, that's where this code block comes in. This is kind of the magic of Kaspresso. It actually, this inside here is a try catch block and a while loop. So it's a try catch block to catch any assertion errors. And it also has a while loop to keep retrying until it succeeds. So it retries every second for up to a minute in this case. And so to be clear, if you truly have broken something in your application, it won't ever work. It'll take a minute and it'll fail. But if your failures are just due to some kind of external ambiguity, we can retry and retry until it works. Now in this case, the ambiguity is my goofy siren being on or off, but this could be a race condition, and this could be like maybe the system's down, maybe your database is over, it's a weird state. Like, so this is a useful thing for dealing with live flaky systems. So let's go ahead and run this test now. Okay, we're gonna run this again. I'm gonna hold the siren up. So the siren's off. Now, sometimes it does it so quickly you can't see the siren turn on or off. But the point is, no matter what state the siren is in, this test will now pass. And again, the big thing we added was this button click, right? This turns on or off. It changes the state of the system and it allows us to kind of retry until it works. So let's just see here. So in this case, I'm running it. Now, what I can do is another cool thing about Kaspresso is you can actually set a filter here. And you can actually, Kaspresso gives you some nice logs. See, it tells you step one. So that's another, like, there's a bunch of nice things about Kaspresso. One of them is a logging, and another is this retry logic. So let me turn the siren on and run this again. So no matter what we do, the test will pass. And also, I meant to say this, but if you have any questions, wait till the end, because we're going to have an open Q&A session. You can turn on the mics and let everybody shout out questions, and hopefully I can shout out answers. We'll see. So again, we can see that no matter what, the test passes. We can just keep rerunning it. So I'm gonna let it go. So we've done it, right? We've done it, we've gone from 0 to 98. We've effectively written test coverage for our existing feature so that we can feel comfortable going ahead and adding new features and knowing if we've made a regression bug, hopefully not, right? So this is interesting, right? So what's going on? Because clearly, you know, we're 20 minutes into our talk, 15, 20 minutes into our talk, and I just told you I'm done. Well, I'm not done, because although this is reliable, this gets us out of the gate. We have 0 to 98% coverage, but the problem here, we still have a problem. So a little more time has passed, right? We've built our new feature, and we're happy. We know a little more about the code. Now we need to go back and revisit our end-to-end tests, right? Because come on, folks, look at this thing. This is rather silly. This has got duct tape, hot glue. It's got wires hanging off of it. This is an unreliable system. Again, it's a metaphor, because you know what? All systems are unreliable. You know, we really try to control for these kinds of external dependencies, right? In any good automated continuous integration environment. Our tests will fail inevitably because of some external problem, such as a database being updated, right? So we want to get rid of the live part of our end-to-end tests. We want to mock out the external dependency of this thing. How do we mock this out? We want to do that. Now, I have to say at this point, I don't want to mock anything inside of the app. I still want it to be an end-to-end test. Now, the funny thing is if you go back a few years and look at some of my talks, you would have seen I said something different about Espresso. I've changed my mind, okay? We're allowed to do that in life. I think to these days, the best Espresso tests are end-to-end tests where you mock nothing in your application. And the reason I say that is because I found that with really complicated large applications, your mocking framework becomes too complicated. It just becomes overwhelming for developers to go in and change things and add new tests. So what I'm advocating is an end-to-end test still for your application. But we are going to mock out our live dependency, right? And that is the Siren. More specifically, it's the particle platform that we're talking to when we talk to the Siren. So how are we going to mock out this external dependency? Geez, because this is tough to do this kind of stuff. I'm not lying to you. It's hard to figure out what to mock and how to mock things. So let's just take this one step at a time. We're getting a little better with the code. We've been in the company for a while, right? And now we know that we're talking to a particle API. So let's open up the code and main Java API. Lo and behold, here we have a particle API class. Boy, that probably is where we want to look if we want to figure out how to mock out our network call, right? The thing is, as I said, I don't want to mock anything in our app. This class is in our app, right? It's in the source tree here. I don't want to mock this, but I know I'm on the right path. So let's take a look at this and see what we can do. Particle API is a dependency like anything else. It's injected throughout the app. And to do that, we use Dagger, right? So let's open up our Dagger component. Okay, so this isn't a Dagger talk. We don't have a week to do that, but Dagger is how we do dependency injection. It's also called inversion of control. It's how we provide our dependencies, right? In this case, if you look down the bottom here, we can see we provide Particle API here. Now remember, I don't want to mess with Particle API. It's part of my app. So I don't want to fake out this. I don't want to mock this. But I see something interesting, sorry. I see something interesting here. It uses OKHTTP client, something made by Square, right? Which is a great library. We all use it to do our network calls. That dependency is created here. So this is it, right? This is interesting. I like this because this is a good candidate for what we want to fake out. Look, I want to use the word fake. It's more generic than mock, right? So we're going to call it a fake. So I want to fake out this OKHTTP client because I don't want to depend on the real network call. I want to do a fake network call when I'm running my tests. Okay. And then another nice thing I like about this is this class isn't in our code base. It's an external class. So I consider this to be an external dependency. I'm okay with mocking this, faking it out. Okay. So how are we going to do that? How are we going to fake out this dependency? We only want to do it when we're running our test. We don't want to modify our production code. Right? That's another nice thing is you really don't want your production code to implicate a particular testing framework. And so we don't want to mock this. Now, years ago, I would have suggested making a test module here and having a whole different dependency here, but I don't want to do that. I don't want to change my, Dagger is complicated enough as it is. I don't want to add more complexity by having test modules. So I don't want to do that. I want some way of swapping out this dependency at runtime when I'm running my tests. So lo and behold, we have something to do that. It's called DaggerMock. Okay, so DaggerMock is, it does just this. It allows you to swap out at runtime things in your test. And so we're going to add a new behavior to our test. And the way you do that is with a new test rule. So we're going to create a new test rule. We're not going to modify production code at all. Oop, I'm going to close that package and we're just going to work inside of our test directory. So let's go ahead and create a new test rule that uses DaggerMock. And remember, our goal here is we're trying to fake out our network layer. In this case, okay, HTTP client. So let's go ahead and do this. We're going to new, and we're going to do, now we're going to name this test rule after our Dagger component, application component test rule. Okay, there you go. Now this is going to extend DaggerMock rule. Oh, no, I don't want that. I want rule. Okay, and application component. The constructor takes two arguments. It takes the class of the Dagger component that you're overriding, and it takes the name of it takes an instance of the module that you're going to be overriding. Now remember, we're not overriding really much of anything. It's mostly going to be the real code. All we want to override is the OK HTTP client, right? So let's do that. How do we do that? We do that with this step here. Again, it's more work in the constructor. And that's what this provides method does. The provides method says, it instructs DaggerMock, hey, if somebody's using this Dagger component and they want to have a client injected, we're going to pass in this fake version instead. So we need to provide that fake version when we create this rule. We instantiate this rule in our test. Okay, so that's going to give us, so when anyone uses the client, such as our particle API does, right? It uses this client. It's going to get this fake one. Okay, that's the first part. Now, one thing I want you to understand is this is an interesting part about DaggerMock and about testing in general of Dagger that's often overlooked, is that, remember, when you do an Espresso test, you're installing, you're building and installing the app and starting the app. Now, the interesting thing is quite often the Dagger component, the Dagger graph is stood up when you create your application object. And so by the time you actually run your test, by the time this test rule starts, you already have a Dagger component alive and well in your app. You need to swap that Dagger graph out with your new mock Dagger graph, right? And that's what this line does. It swaps it out right before your test is called, or right before your activity is launched, right? Because the test rule is going to do this. It's going to swap this out for us. And remember, this is going to be end-to-end, the whole application, not mocked at all, except for this external dependency that is the client. Okay, that's our rule. Let's go ahead and use our rule now to make our test more reliable. Now remember, we're going to make our end-to-end test more reliable by extracting out the external dependency, by swapping it out with this fake network call. So let's go ahead and do that right now. We're going to open our unit test back up. Now we're going to put our rule up here that we just built. We're going to put it up here where all the other rules live. Okay. Here's our new rule right here. And here we're passing in our fake client. And the cool thing is we're actually giving it a real network client. We're giving it OK HTTP client. And the reason we're doing that is because we don't want to have to pretend to do a network call. Actually, it's a lot of work in doing HTTP, right? So we want to have all that just real and just make a real HTTP call. But what we're going to do is we're going to use the interceptor feature of OK HTTP client and inject a mock interceptor. This is another class provided by those loving folks at Square. And now what mock interceptor does is it takes a network call right before it goes out over the wire, right before I send my request, my request out to the RESTful endpoint that is Particle API. This mock interceptor is going to intercept the call and return back fake JSON. Okay, how cool is that? So let's go ahead and run this test we have sitting here right now. Arguably, once I do this, I can remove all this retry stuff, right? If I'm not going to bother. You can leave it in, but none of this stuff's necessary because we're not going to talk to the real siren anymore. It will always be in exactly the right state. So let's go ahead and run this test and see how it works. Run. I hope I click the run button. We'll see what happens. All right. Again, we're going to go down here. We're going to watch the logs. It's installing the app. Drum roll. I'm drum rolling. Can you hear the drum roll? I don't know. So again, I'm going to install the app. I'm going to use our new, oh, it crashed. What happened? So actually, I knew it was going to happen. I knew the crash was going to happen because this is actually the right way, in my mind, to use mock interceptor. And that is we don't configure it right away. We don't try to mock every possible network call our app can make. It could be, it's just too much work, right? Too much work. What you want to do is you want the test to tell you what network calls it's making. And that's actually what's happening here. Mock interceptor is complaining and it's saying, hey, you're trying to make a network call, but you didn't tell me how to respond to this network request. So we need to configure the mock, right? Which is something we all, which for those of us who have done testing, know you need to do. You need to configure your mocks. So we need to create a test rule in mock interceptor to tell it how to handle a siren state request. This is the app asking for the state of the siren. So we're going to put last piece of code here. Okay. All right. Let me let you look at the code here. I'll get rid of all these windows. Okay, so this is what we've added here. Okay, we've added that just now to our test. Down here is where we launched the test, right? And here is where we're configuring mock interceptor. Okay, so what we're telling it, remember, here's our error we got. So we marched through our test and we got this error. And so we create a rule that captures that particular path. And so if this mock interceptor, if it sees this network call happen, it returns back this JSON. It's a string. It returns back the actual, literally the JSON response from the endpoint. But here's a cool thing that I like to do here. I use the actual response object that it's part of the retrofit code that I use, right? And the reason I do this is, and this is where I tell it that the siren's off, right? That's how I do that. And the reason I do that is because, you know, APIs can change over time, right? And if I just put raw JSON in here, I just had some kind of like, you know, raw JSON pasted into here, that JSON could become wrong over time because of a changing API. And so if you do it this way, you kind of do it backwards. You instantiate the object and then you render the object, you render the JSON from the object using JSON. That way, if your API changes, your test has a compile timer. That's one little extra detail that I want to add. If you're mocking tons and tons of things, this really becomes arduous, and it might be better just to use raw JSON. It's up to you. Anyway, let's see if this works now that I've mocked out. I've configured this thing correctly. Let's run this test again. Oh, and I'm going to turn on the siren, right? I want to turn on the siren because this should make our test fail, right? But because we're using a mock, the test should pass. Oh, actually, since we're using Kaspresso, it should turn the siren off, right? Remember that? But it's not going to do that because it's not making a network call. It's using the mock external dependency and the test passed. So now that's great. So we've done it. Now we have a reliable mock end-to-end test that we can use to kind of protect us, right? From you know, regression mistakes that we may make in our app. Now, one final footnote I want to say here is that you really want to go back and write your unit tests because there's no replacement for proper unit testing. So you have to go back and over time write your unit tests so you have proper 98% coverage from unit tests instead of going from 0 to 98 using instrumentation tests. So that's actually it for my talk. Now, Christian, if you can open up the lines, that's how we say, and let's hear what folks. Let's hear questions folks might have.
For sure.
And folks, you can turn on your cameras if you want, and open your mics and ask away, ask questions. Or maybe if it gets too crazy, we can raise hands. But let's just start by asking questions, see what happens. Hey,
Probably let me start. Thank you for presentation. That was an interesting one. And my question is that you mentioned that, okay, in case if it starts flaking, we have this flag something in Kaspresso. And if there is a race condition, then the test will still be green after a few iterations. But the question is, how to decide if it's okay for us that, okay, there is some race conditions? Because maybe it's the other side that if the real user will actually see the same thing, that the test fails in terms of like a product requirements or something like this, because actually there is a race condition somewhere out there. And yeah, that's the question basically.
Yeah, it's a great question. So Artur's question, if anybody didn't catch it, he's basically saying, what if there's so we created this code block, right, to kind of cover flaky problems with the endpoint, right, the styrene. But Artur is asking, I believe, what if there's a flaky problem with your code itself, right, Artur? So what if every third time the user tries this feature, it crashes? It's a great question. And this test won't catch that. This is, it's 0 to 98 in 12 minutes is what we did. And it's a starting point. So that mock stuff that you should be doing, you should be doing that quickly. And then you should be having unit tests. And so it's a good point. You could have race conditions in your app. And I would say though that, the retry mechanism, it doesn't try that many times. You could constrain your in this case, for example, we know that we could constrain the retry attempts to just 2, right? Because the state of the things is on or off. Mm-hmm. So if I did that, the chances of actually, catching a race condition in the app are less. But you're right, it's a great point. It's not 100% solution. Great point. Excellent
does
point.
It log basically what are the tests that are flaky? So later on I can check out if basically I expect them to be flaky or not, or something like this.
I apologize. I didn't. Could you please say that again, please? Try again.
Yeah. The question was, does Kaspresso log out? Basically, does it log in like app log or basically in terminal that, okay, this test is actually flaky?
Right. Who just spoke? Who was that just spoke? Thank you for that. But I want to know who just said that.
Yeah, that was still me, basically, Artur.
Oh, it was you? Oh, Artur, I'm sorry, Artur. Your head's like this big on my screen. Your head's like this big on my screen, so I didn't see your lips moving. I'm sorry, Artur.
No worries.
That's a great point.
Yeah.
It's a great point, right? So with the logs, you can help you out, right? It's a great point. I think Kaspresso has got. I didn't even mention all the cool things Kaspresso can do. I think it's a really promising library. I think folks should definitely check it out. And I just want to give a shout out to the folks at Kasparov, the people that made it, and Square. Our lives without open source would just be a very dismal place. So thank you to to those folks who wrote this, because I really appreciate it. The funny thing is, truth be told, I actually had a try catch block and a while loop in my code, and then a colleague of mine, Ben Miller, mentioned, hey, I see this thing called Kaspresso, and lo and behold, you do that. You do a try catch block with a while, and so it was a great idea, and it makes the code look simple. They also do cool things like screenshotting, all kinds of cool stuff. Are there any other questions? Christian, I believe we go to 150. Is that correct?
That is correct.
Yeah, we can go over if we have to, or not. I mean, it's always great to have some time to take a break in between talks. Are there any more questions? Okay. Well, if there are no other.
Yeah, can I bring one more question, basically, that is similar to the one that you discussed about API change? So because you are using this like model to JSON, we will catch if the model changes, and then maybe like a test will fail or something like this. But do you have maybe some like other means of making sure that if API changes, then basically you will know about it? Because in a big project, when there are lots of API, there are like some cases when API has changed and the client developers were not notified about it, and basically something fails. And of course, ideally there are some like API tests and stuff, but anyway, is there a way, like in your experience, how to quickly understand that API has changed and basically that developers of the client apps need to react on this change?
Yeah, sure. I mean, we use tools at Comcast. We actually have a whole, typically the way it works is we have a platform team that builds the APIs. And then we have the, all the different client teams that consume those APIs. And we use things like Swagger, and we use code gen tools that actually, the platform team actually generates all the different technologies necessary. So they generate Kotlin code, they generate Swift code, all the different code necessary for any client to consume that platform. So we actually use the client code we use, like this at Comcast. This class right here would be actually created by the platform team, and we pulled in as a dependency. And so it just so that helps us to know that we're using the right versions of things. And also these classes get passed around, so you'd have many compile errors if you're trying to talk to an API in some way that was no longer supported. You'd probably have a compile error first before the test didn't work. You know what I mean? If that helps answer your question.
Yep, got it. Thank you.
Mm-hmm. Yeah, thanks for the questions. They were great questions. I appreciate it. Any other questions? And again, I just want to say that this is not a substitute for unit tests. You still have to write unit tests, but they do require a real in-depth understanding of your classes within your app, which is why this idea is great for folks who are just joining the team or adopting old code, trying to use old code for new things. That kind of thing. Okay, that's it. I think. Thank you very much, everyone. And Christian, I think you can, if you want to sign off, say goodbye to everyone or whatever you do.
Yeah, that's no problem. Thank you, everyone, for joining. We're going to stop the recording. If no one else has questions, just want to do a double check. Doesn't seem like it. Okay. Thank you so much, Nick. What a great presentation. And thank you, everyone, for joining.
Thanks, folks. Bye-bye.